Hello everyone, welcome to lecture number 2 of the 4th week. In this lecture, we will explore and analytically prove the theorem Cauchy root test. As its name suggests, it was proposed by Cauchy and it is related to the root test. That means we have some situation where each term is going to be nth root of the series, right? So, we will see some examples and the statement. So, let me give you a statement. A statement has been made similar to the statement with comparison test, limit form of the comparison test, in which we have L is not equal to 0 and then we conclude the series is converging and diverging. So, what will be the Cauchy root test? If is a single series, that means capital sigma un is a positive term series is given such that each term, see here, taking the nth root of the each term and taking its limit n tends to infinity un to the power 1 by n is equal to L. Then the series is converges depending on what is the value of L. Is it less than 1? It is less than 1, then it converges. If it is greater than 1, then it is diverges. Strictly less than 1 and strictly greater than 1. What happens when L equal to 1? There is no conclusion, so test fails. There is no conclusion, because there are some examples where some series when L equal to 1 is converging and the other are diverging. So, that is why there is no conclusion at L equal to 1, right. So, case 1, how to prove the case 1? As L is less than 1, so similarly here you can see here. So, this is 1, this is 0 and the whole series is lying here. So, L, the value of L lying between 0 to 1 or let us say less than 1, then I can have this L plus 1, I can choose this value L so that L plus epsilon is still less than 1 and that is name it L plus epsilon as alpha. So, I have chosen L plus epsilon is equal to alpha such that it is still less than 1. That is our idea. So, let us select a positive epsilon such that L plus epsilon equal to alpha and less than 1, right. Now, use the definition of limit. So, limit is given un to power 1 by n tends to infinity is equal to L. So, by the definition of this limit, for epsilon is greater than 0, there exists some number m, a natural number m, such that what happens? Each un 1 by n minus L modulus is less than epsilon for every n is greater than m. So, that means L minus epsilon and un 1 by n is less than L plus epsilon, right. And now take the n square of all those n power. So, taking L power, this will gives you L minus epsilon per power n is less than un is less than L plus epsilon per power n, right. Now, L plus epsilon is given, I have chosen this one. So, un is less than alpha per power n and this is happened for every n is greater than or equal to m. So, now alpha n is a geometrical series and since alpha is less than 1, we have chosen this one in this way that it is less than 1. That means it is a converging series and henceforth by comparison test, which comparison test? By the comparison test, the first one, the series un is converges. Since in the series we have un is less than equal to k into vn and if it is happens then the series un converges if series vn converges. So, series vn is what? Series vn is alpha n here. So, and this is a geometrical series, and it is a converging when alpha is less than 1 and that is why vn is converging and leads to un is converges. For To show that this is for L is greater than 1, it is going to be diverging. Use this one. You remember always this one. This is the equations where you have to remember this one. So, for case L is greater than 1, so we have here 1, this is 0, this is L, this is L. So, now I am choosing this one L minus epsilon somewhere here each side. So, L minus epsilon equal to beta such that it is also greater than 1, right. And now look for this, look for left hand side inequality. So, this is happening as beta p power n is less than un. So, this means if I choose beta n, and remember this one, what is the beta value of the beta? Beta value is greater than 1. That means it is a diverging sequence geometrical series, and it is a divergent geometrical series. And here beta n is less than un. That means un is also going to be diverging series. Un is also going to be diverging series. The test fails at L equal to 1. So, to show that test fails, you need to show the examples. There is no need to do the mathematical calculations analytically. You have to counter examples for one series is going to be converging and another series is going to be divergent, but the limit must be 1, right. So, choose one series which is known. So, series 1 by n. 1 by series known as a diverging series. So, this is divergent series, right. Now, take the limit n tends to infinity un p power 1 by n. So, this means limit n tends to infinity 1 by n p power 1 by n, right. And what is the value of this? This is obviously 1. So, this is the limit is 1. Now, choose this one, summation 1 by n square. This is a convergent series. This is a convergent series. We all know this. This is the P series where P is greater than 1. So, that is why it is a convergent series. So, comparing with summation 1 by np, right. So, it is a converging series when P is greater than 1. So, it is happened. And now, find out the limit n tends to infinity 1 by n square, and that is power 1. And if you do the calculation, it will gives you 1, right. So, that means one series which is convergent having the same limit L equal to 1, and another series which is divergent having the same limit as L equal to 1. We are not reached at any conclusion. That is why if limit becomes 1, the test fails. There is no conclusion at all. Now, use this Cauchy root test to solve and to test the convergence of some given problems. Test the convergence of the series whose general term is 1 plus 1 by root n minus n p power 3 by 2. Remember that Cauchy root test is often useful for to test the series, such series where the terms are in powers or some roots. That is the idea where it is going to be useful. So, if terms are in the some power or some roots, then you are going to use that test, Cauchy root test. So, here each term is given. So, series 1 plus of 1 by root n, and that is by power minus n 3 by 2. Here it is given, right. So, obviously, I mean, if you go through the comparison 1 test, comparison 2 test, that will not be going to be useful. If you go with the nth partial sum of the series and try to find out that sequence is going to be converging or diverging, it is not going to help you. So, obviously, you need a particular test, and that particular test is Cauchy root test, right. So, use this one. Un is given, un is here. So, I have to calculate un limit of n tends to infinity un p power 1 by n. Now, calculate this one. how much the value? It will comes out, I will calculate for you. So let me 1 plus of 1 by root n, and this is minus n 3 by 2, right? And then for this, so 1 by n. So calculating this, it will gives you 1 plus of 1 by root n, and this will comes out to be minus, and this is cancel out, and this will comes out to be minus n 3 by 2 minus 1. So this will going to be minus n half. So this is nothing but limit n tends to infinity 1 divided by 1 plus of 1 by root n, and 1 by root n. No, root n, right? This is root n. So this will gives you how much? This will gives you e. This will gives you e. So this will gives you 1 by e, which is less than 1, which is less than 1, because e has the value between 2 and 3, between 2 and 3, 2.7, 2.713. So 1 by 2.71 is less than 1, and by Cauchy root test, if the limit is less than 1, so this will give you the whole series is convergence series. Look at test the convergence of the series for a series which has a term 1 by 2 pi power n. Again the un term, un is equal to half of n is in the power of n, or therefore we are going to strictly directly use the Cauchy root test. So calculating a limit n tends to infinity un pi power 1 by n, right? So this will give you 1 by 2 pi power n, and this will give you 1 by n, and taking limit n tends to infinity. So n cancel out. So this will give you limit of, so this will give you directly 1 by 2, right? 1 by 2 is less than 1, henceforth by Cauchy root test the series is convergent. Discuss the convergence of the series an when now look at the terms. When n is odd, this is 1 by 2 pi power n. N is even, then 1 by 3 pi power n. This is the series. So series is something like this, summation of an, where an is equal to 1 by 2 pi power n and 1 by 3 pi power n. And that means this is odd one and this is even one, right? So that is the idea to do this. How to prove this one? So the expanding the series, so this series can be written as the odd one, that means 1 by 2 pi power 1 is equal to 1 by 2, and the even one, that is 1 by 3 square equal to 9, and this is equal to 1 by 2 ka cube equal to 1 by 8 plus of 1 by 9 into 9 equal to 81, and plus of so on. This can be written as 1 by 2 pi power 1 plus 3 ka square plus of 2 ka cube plus of 3 pi power 4 plus of 2 pi power 5, and so on, right? That is the idea. So can we find out some odd and even terms? Yes, we can. So calculating the odd terms, this is the odd terms. So a2n minus 1, I can write this one as 1 by 2 pi power 2n minus 1, is it given here, right? So and a2n, that is 1 by 3 power 2n. So a2n is nothing but 1 by 2 pi power of 2n minus 1, right? 2n minus 1 and 1 by 3 pi power of 2n, that is given, right? So both have. Now taking the limit of un pi power 1 by n, n tends to infinity for each a2n minus 1 and a2n. So limit a2n minus 1 and divided by 1 by 2n minus 1, right? We had here, right? So we have limit un pi power 1 by n. Now I have taken un as a2n minus 1. So that has the limit as a2n minus 1, right? So that will gives you 1 by 2, and another one, that is limit of a2n pi power 2n, right? So this will give you 1 by 3, and both 1 by 2 and 1 by 3 is less than 1. and henceforth the series is convergent by Cauchy root test. Discuss the convergence of the series. Look at the series. It also in the power and roots and so on. So that's why we are going to use Cauchy root test. Firstly, to calculate the Cauchy root test, look at each term. This is the first term, this is the first term, this is the second term, this is the third term, and this is the fourth, fourth, fifth, and so nth term. Can I identify the nth term? We are going to identify the nth term. Remember this one. So look, focus on the second term. The second term containing the 3 and 3 and 3 here and 3 here, and then the second term is here. Now do the same thing. Just look at here. So this is nothing but n plus 1 by n power n plus 1 minus n plus 1 by n power minus n. So I am calculating for you, let's say A3. So this is going to be 4 divided by 3 power 4 minus, this is 4 divided by 3 and the whole power minus 3. You can compare this one, the third term here, 4 power 4, 3 power 4 minus 4 by 3 power minus 3. We have that can be written as, we have here 4 power 4 divided by 3 power 4 minus of 4 by 3 and the whole power minus 3. This is the same as a third term it is given here, right? That means n can be written in the form of this. And now calculate limit n tends to infinity n power 1 by n, right? So calculating this one, as limit value are approaching going each one, so you can have this, the one limit, the whole limit here, right? So this will gives you 1 plus of 1 by n power n into 1 plus of 1 by n minus of 1 minus 1 by n power minus 1. So this will give you e power e minus 1 power minus 1. That means 1 divided by e minus 1. What will be the value? Value e is equal to 2.71. So it's roughly 1 divided by 1.71, and which is obviously less than 1. So by Cauchy root test, this series is convergent. Now the next question is also very good, and it contains the first time as a variable x. So if x is greater than 0 is given, and there is no fixed value for x, so it is just greater than 0, and we have to test the convergence of the series whose nth term is given, xn or an is x by 2 power n 1 by of nq. This is the nth term of the sequence for the series summation un, and we are going to test this summation an. So obviously it contains the powers and roots right here. Therefore we are going to use Cauchy root test. To use the Cauchy root test, we have already identified an. Henceforth I am going to calculate n tends to infinity limit an power 1 by n, and that means x by 2 power n into 1 by n q and whole power 1 by n, limit n tends to infinity. That's our idea. And what will be the value? Look at this one. So this will give you limit of n tends to infinity x by 2 and n cancel out here, and this one will give you n power 1 by n and whole power 3, right? You can exchange this one, right? So that will give you how much the value? This will going to be 1 and this will going to be x by 2. So this is x by 2. Now x by 2 is less than 1, x by 2 is greater than 1, depending on what is the value of x itself. So it is convergent, since x is greater than 0. So x by 2 is less than 1, and that means x is less than 2. So whenever the x lying between this 0 to 2, the series is convergent, and when it's outside, the series is divergent. But at x equal to 2, the test fails. Test fails. We need the more stronger test to testify, to investigate the convergence of that series. So we have here, depending on the x, so we have here 0 and 2, and if x lying between these two, the whole series is going to be convergence, and if it is not lying, x is greater than 2, strictly greater than, it is diverging, and x equal to 2, equal to 2, we need test fails. We need some higher test, right? So that's the answer. Similarly, again, look at the series whose nth term is given. So an is given a square n minus 1 divided by n root n, right? This is the nth root of n. Okay, so I'm going to use erasure here and write all those. So this is a to n minus 1 divided by nth root of n, that is given. So I'm going to calculate this one. So calculating limit a n to power 1 by n, calculate this one and simplify it. This will become 2 1 minus of 1 by n, and n into 1 by n, nth root of this 1 by n. Okay, it's not in nth root, it's not in nth root, it is product of this, right, square root of n. So there are two different terms here, and if you calculating this will gives you this will going to be 1, this will going to be 1, so this will going to be a square. So the limit a n n is equal to a square. Now a square is always greater than 0, but we have to compare. For the convergent, a square must be less than 1. So what will be the value of a? Okay, so see here, this is minus 1 to 1, and a square is less than 1. So a must lying between minus 1 to 1. So this is the value. This is the value. You have to compare this, right? So taking a equal to 1 by 2, a square is equal to 1 by 4. So this is less than 1, right? And so on. A equal to minus 1 by 3. So a square equal to 1 by 9, which is less than 1, right? So that's how the idea has. So if a has the range minus 1 to 1, then the by Cauchy root test, this series is convergent. Another series, look at another series in which you have a power of the terms in the power. So an is given, this is 1 plus n divided by 3 plus n, and the whole power n square is given, right? Now I am going to calculate limit n tends to infinity a n power 1 by n, right? So do this the calculation. So limit n tends to infinity 1 plus of n, and n square into 1 by n divided by 3 plus n power n square into 1 by n, and n cancel out here. So this will gives you limit n tends to infinity. In the denominator we have 1 plus n and power n, 1 plus 1 by n, sorry, yeah, and the next time we will do this. So divided by 3 plus of n power n, this can be written as limit n tends to infinity 1 plus of 1 by n power n divided by 1 plus of 1 plus of 3 by n power n. The value of this is E, and the value of this is EQ. right. So, this means cancel out. So, this will be E square, and what will be the value of E? Equal to 1 by, roughly it is 2.71 square, and how much the value of that roughly is coming out less than 1. So, by the Cauchy root test, the series this one which is given here is convergence series. As you can see that as the problems are very complex, then you can use containing the powers, roots, sorts and indices, then such type of problems for which you need to investigate the convergence of the series, always try to use the Cauchy root test. Cauchy root test will give you a flexibility to test such type of convergence by just calculating one limit, that is limit a n power 1 by n. If limit is less than 1, it is the whole series is going to be convergent. If L is greater than 1, that is limit is greater than 1, it is divergent. But make sure that if limit becomes 1, or you will find the limit a n power 1 by n equal to 1, the test does not do anything. So, test fails here, and there will need a further test or further approach, further concepts of the reanalysis to find out, to test the convergence of such series. So, thank you so much.